P-values for determining linear correlation. In example 4, we used the computed value of the linear correlation coefficient where R was equal to 0.591 and compared it to the critical R values of plus or minus 0.878 found from the table. In the real world of statistics applications, the use of such tables is almost obsolete. Later in the course, we will describe a more common approach that is based on what we call p-values instead of tables. The computer software displayed that was in example 4 shows that the p-value is 0.29369 or rounded to 0.294. So let me go ahead and show you where that information is. So again, the p-value that we got from the computer display is the following. So if you look down here, here's where the display is. It says p-value, and the value for that was 0.29369. And when you round it, you get 0.294. Now, p-values are going to be introduced later in a more in-depth way, but here is a preliminary definition suitable for the context of this section. If there is no linear correlation between the two variables, the p-value is the probability of getting paired sample data with a linear correlation coefficient R that is at least as extreme as the one obtained from the paired sample data. Now again, based on the computer display showing the p-value of 0.29369, we know that there is a 0.294 probability, or if we converted that to a percent, that means it would be 29.4% chance of getting a linear correlation coefficient of R being equal to 0.591 or more extreme. Now, assuming that there is no linear correlation between shoe print length and weight. Now, the values of R that are at least extreme as 0.591 are the values greater than or equal to 0.591 and the values less than or equal to negative 0.591. Now, how do we interpret a p-value? Now, if you take a look, the p-value of 0.294 is high because when you look at it as a percent, it's 29.4%. It shows that there is a high chance of getting a linear correlation coefficient of R, which is equal to 0.591 or more extreme, by chance when there is no correlation or no linear correlation between the two variables. Because the likelihood of getting R, which is equal to 0.591 or more extreme value is so high, which again is 29.4% chance, we would conclude that there is not sufficient evidence to conclude that there is a linear correlation between shoe print length and heights of males. Now, one important concept that we need to think about when we're talking about p-values and later on in this course, only a small p-value, such as 0.05, which is much smaller than that 0.294, or less, or again, 0.05 is the same thing as 5% chance or less, suggests that the sample results are not likely to occur by chance when there is no linear correlation. So a small p-value supports a conclusion that there is a linear correlation between the two variables.